This video contains some problems about continuously compounded interest. So the first problem, and what I'm going to do is set these problems up, and then we will solve all problems together. So we'll pull out a calculator at the end. So first, how much money will you have in your account in 2 years if you deposit $10,000 today and the account earns 2% continuously compounded interest? So we want to calculate the future value in 2 years of $10,000 earning 2%. So that's going to be e to the 0.02 times 2. The second problem is how much money do you need to deposit into an account earning 4% continuously compounded so that you have $20,000 in 3 years. So that's a present value calculation. So this is $20,000 e to the minus 0.04 times 3. Again, if we're taking a present value, we're discounting, we multiply by e to the minus RT. If we're taking a future value, we're growing, we multiply by e to the RT. Finally, how long would it take a deposit of $75,000 to grow into $100,000 at 1% continuously compounded? All right, so this is our present value. This is our future value. So $100,000, we can use either the present value or the future value equation. I'll use the future value. $100,000 is $75,000 e to the r, 0.01, times t, and we need to solve for t. Okay, so we just need to solve for t, so that's 100,000 divided by 75,000 equals e to the 0.01t. This is 4/3. We take the natural log of both sides, so natural log of 4/3 is equal to 0.01t. Multiply both sides by 100, and t equals 100 times the natural log of 4/3. So now let me pull out a calculator and calculate these values. So 10,000 times, that first one is 0.02 times 2, which is 0.04. 0.04 second e to the x equals 10,408.11 equals 10,408.11. The second one we calculate by doing 20,000 times, that's 0.12 negative e to the x equals 17,738.41. So equals 17,738.41. And finally, we need to calculate 100 times the natural log of 4/3. So 100 times 4 divided by 3 natural log equals 28.77 years. So t in this case equals 28.77 years. Now I would expect you to be able to both calculate future values and present values, but also manipulate these equations so you can find either interest rates or the time to grow or discount money, the time to grow money from, say, 75 to 150 or $100,000.